All right, this is our last example, so take 1 minute, see if you can solve this system of equations by graphing, and we'll go over it in 1 minute. 1 minute, go. All right, solve this system by graphing. No problem, let's do it. But before we graph this, and yeah, I'll be doing this one in red, let's change these into slope-intercept form, okay? So that's a negative 2x plus y equals 1. So I'll zero out the negative 2x's by adding 2x to both sides, which will zero that out, and now I'm left with y. I'll drop the y equals 2x and positive 1. Now the coefficient of y is already phantom 1, so I don't need to perform that second step. I can see right here that my slope is 2, or 2 over 1. And since the 2 is positive, that would be up 2, and then to the right, 1. Up 2 to the right 1. Well, up 2 to the right 1 from where? That's our y-intercept, which is that plus 1 right there. But again, it's an ordered pair, 0, 1. And then we'll do the second equation in purple. 4x minus 2y equals negative 2. So I'm going to subtract 4x from both sides. Zero out my x's, drop my negative 2y. Remember, it keeps that operation to its left as its sign. So that's a negative 4x and negative 2. Again, we cannot combine those because they're not like terms. Now divide all the terms by the coefficient of y, which is negative 2, to make it a phantom 1. So now y equals negative 4 divided by negative 2 is 2x, and negative 2 divided by negative 2 is positive 1. So that tells us the slope there is 2, but again, I'm going to show it as a fraction, 2 over 1. And since the 2 is positive, that would be up 2. And the 1 in the denominator is the run, which is to the right 1. Up 2 to the right 1 from where? Well, that's our y-intercept that we need. On this one, that's a plus 1 right there at 0, 1. So let's go back to the graph then. Yeah, we have all the information we need. I'll start with the red equation, starting with the ordered pair 0, 1 right here. And then my slope being 2 over 1 means I would go up 2 to the right 1, up 2 to the right 1, up 2 to the right 1, up 2 to the right 1. All right, and I'm going to continue this backwards, so left 1 down 2, left 1 down 2, left 1 down 2, left 1 down 2, left 1 down 2. And I'll go and make this graph. Graph the line there. Something like that. And then let's do the purple line as well. So 0, 1, that would be the purple ordered pair right there. And then the slope up 2 to the right 1 gives us this point, up 2 to the right 1, up 2 to the right 1, up 2 to the right 1. And we can see that all these ordered pairs are falling on the same line. So even when I graph the purple line, let's see if I can do that a little better. Something like this. What we find is that these two lines, and again, the objective is the solution to a system is the point of intersection between the two lines. But this one, it doesn't just have one intersection. We've seen an example with no intersections. This one it's intersecting everywhere. So in actuality, this one we would say just has infinite solutions. Because it's going to intersect here and there 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 and everywhere, even places off the graph out here and to the side. Okay? So this one, we won't declare any one specific solution. This one just has infinite solutions. So that brings us to the story of lines. And this is nice because lines, they'll either intersect everywhere, like we see here, at least straight lines will, which is great because they have a lot of in common, right?